Hello everybody, welcome to the new video. In the last video, we spoke about when the graph of the function exists and how you can calculate the limit of that immediately. But sometimes it's tricky because you haven't any graph and you must calculate the limit of everything by the formula. And some of this formula is a little hard. By the way, example, if your fx is x power 2, 3 and 2x minus 1, if you're gonna to calculate the limit of x approach to a, easily you just calculate it. Exactly, you just use this point in the function and you can obtain to 1 plus 2 minus 1 is 0. But always is not so easy like this, because for example, if you're gonna to calculate the limit brace or bracket x2, x goes to 1 over 2, or limit exactly the same function, x goes to 2. Although the functions are the same, but the result and how you're going to calculate it is totally different. In this time, immediately you put it in the brace, and that is 1 over 2 squared is 1 over 4, and you know the brace of this exactly is 0. But in another one, you couldn't calculate it so easily. You must obtain the both-sided limit x over 2, x goes to positive side, and limit x2, x goes to negative part. Guys, I gotta give you a cheating. The positive part is 2.1 and negative part is 1.9. If you put it in here, 1.9 with power 2, absolutely you know is less than 4, yes? Okay, the bracket of 4 minus, if you consider 1, 2, 3, 4, 4 minus, you know, is here, and the brace of them is 0, but 2.1 over 2 we know is positive 4, and the positive 4 exactly is inside, and the brace of positive 4 is 4. Yes, they are not same. In that place we hadn't any limit, but exactly that formula we had exam in 0.1 over 2, but in the 0.2 we haven't any limits. But if you can guess what happened when you have the brace and inside the brace is belong to z, yeah, you must, if you're going to calculate the limit, you split the limit to the both side positive and negative part, but it doesn't belong to z. Inside the brace it doesn't need. For example, in the limit to x plus x minus 1 is goes to the 0, and that one exactly fx limit fx x goes to 2 over 3. In that one you don't need to split the limit because 2 over 3 is not belong to z, but 0 is belong to z, and if you're gonna to calculate this, you must split to the both side. Okay, therefore it's so important, notice. And another function has a disaster is in triangular function, tangent and cotangent. Therefore, passage 2, in triangular function, guys, sinus and sine and cosine always is okay. We haven't any problem with them because they are continuous in all the domain. But the tangent and cotangent are not continuous all the domain, and in that places it has a problem. The tangent, in which point it has a problem, and maybe the limit in that point I'm can say in 90% in that point has a problem is pi over 2, 3, also minus and positive, 3 pi over 2, positive and minus, and odd p or pi over 2. But cotangent is in 0, positive minus pi, positive minus 2 pi, and blah blah blah. For example, if I tell you the limit of tangent x goes to the pi over 4, immediately you didn't need to split it to the both sides because it's not this point, and immediately you just calculate tangent p over 4 and you know that is 1. But if you're gonna to calculate tangent x approach to pi over 2, because it's belong to these classes, you must split to the both side, guys, and therefore limit tangent x goes to a positive side, and the limit tangent x goes to negative part. I don't know what's your information, how long is your information about triangularity, but if you consider this circle, this is a tangent axiom, and this is cotangent axiom, and in here it is cosine and it is sine. Okay, we know is 0, pi over 2, pi, and 3 pi over 2. Yes? Okay, we're gonna to calculate pi over 2 in the right side, exactly, maybe this point. You know, from this part, you never intersected to the tangent line, but you must through and intersected in this part is minus infinity. Therefore, the limit of tangent in the right side, exactly, because we are in the right side, yes, is minus infinity, and in the left side, maybe in this point, when we follow it, and they can intersect it in the positive infinity, and the answer is positive infinity, and we understood the limit value is not happen, because not only they aren't infinity, but also they aren't equal minus infinity and positive infinity. But in other approaching points, for example, in tangent x goes to the 3, 4, 5, every point without, as I mentioned earlier, we had a problem. Or another one, for example, limit cot x. I'm gonna get it a little difficulter then. X goes to the pi over 4, this minus 1. Okay, at the first step, do you think this need to be split to the two part or not? We can immediately put this point in the function and evaluate it. Some of the students, they told me, in this point, we need to put the split the cotangent. Yes, but the cotangent is inside the brace. And the brace, when we must split that, the brace, when we must split it to the both side, is belong to z. And we know the cotangent pi over 4 is 1, and 1 is belong to the z, and therefore this function we must split to the both side, one side, and limit of x approach to pi over 4 in positive side. Okay, you know, we are in here exactly in pi over 4, we are in the 1, but a little less than this. Maybe it's this point, guys, maybe this is this point, yes, and we follow that if it's 1 is plus 1. Therefore, when we are in less than pi over 4, the value of the fx is 1 positive, and to brace 1 positive minus 1, you know, is 2 minus 1 and is 1. But another one, 2 in the right side, you are not exactly 1, 1 minus 1. And 2 minus 1 minus 1, you know the brace of this is 0, 2 plus 0 is 0, minus 1 is minus 1. And therefore, the both side and left side is not equal and you haven't limit. But another part you must be aware of this is root square. The root of some sentences. For example, the root of absolute value, the root of denominator. Guys, you know, A, B. We say numerator, we say to this denominator. If you have a function, for example, fx, gx, they are two functions. This function root is x equal to a. If x goes to a, I can say you 90% of the time you haven't a limit, but you must split the function. Why? I can tell you with the example better. Limit x2 minus 1, x minus 2, x goes to the 2, and another one, limit x2 exactly the same formula. X minus 2, x goes to the 1, for example. Okay, yes. In that one, we must split it to the both sides, but in that one is not needed because x minus 2 equal to 0, x is 2. This root of the denominator, and when the limit goes to the root of the denominator, you must split it to the both sides, but in other one, it doesn't need. For example, in here, I just put this point in the top and above of the formula. Therefore, we can get this part, 1, 2 minus 1, 1 minus 2. Yes? The top is 0, 1, and answer is 0. But about this, we must put it in the both sides, minus 1, x minus 2, x goes to positive, and limit x2 minus 1, x minus 2, go to the negative side. Okay, guys. Positive 2 power 2 is positive 4 minus 1 is 3, but positive 2 minus 2 is 2.1 minus 2 is positive 0. And we know the number divided to the 0, limit is 0, not exactly precise 0, guys. This 0 is not exactly 0, it's near to the 0, okay? Therefore, the number divided to the 0 is positive, because positive divided to the positive is positive, and that part is positive infinity, and then in the bottom is negative 0 and 3 and is minus infinity. Okay, guys, you must consider in root of the absolute value, the condition is the same. For example, if you're going to calculate, so simple question, limit x minus 1 in absolute value divided to x minus 1, x goes to the 1. But exactly this formula, x minus 1 in absolute value, x minus 1, x goes to the 2. Because although in here not only is root square of denominator, but also it's root square of absolute value. And I just mentioned in the root square of absolute value, when the limit approaches to this point, you must split it. Therefore, you must split to the both sides, limit x minus 1 in absolute value, x minus 1, x goes to positive 1, but another one, x minus 1 in absolute value, x minus 1, x goes to 1 minus. Okay? Positive 1 minus 1, 1.1 minus 1. The answer is positive. Okay? Therefore, it goes back without any minus. Therefore, the answer is x minus 1, and in the denominator x minus 1, and they can cancel each other, and the answer is equal 1. But in other part, negative 1 is 0.9 minus 1. The answer is negative 0. And the negative 0, if it's gonna to come out from the absolute value, you must put it with, you must cover with the minus. Therefore, it is minus x minus 1, and the denominator is x minus 1. They'll cancel each other, and we obtain minus 1. And they are not equal, and limit not exist. But the other one, also, the root of denominator and root of absolute value is not 2, and therefore we don't need to split this function. Immediately we can calculate it by just putting this point in the formula, and therefore is 2 minus 1 in absolute value, 2 minus 1, and up is 1, 1, answer is 1, and limit exists. Okay guys, thank you for watching our video. I wish you all the best. Take care. Bye bye.